I'm all alone up here, guys. I know.
What is that?
You ready to go? Okay. Let me have your attention. Let's begin. Welcome to the University of Tennessee Nuclear Engineering Department Colloquium Program. My name is Lee Dodds, and it's my privilege to introduce today's speaker, who is Mr. Jon Rupert. He is the Vice President for Unit 1 Restart of the Browns Ferry Nuclear Plant, Tennessee Valley Authority, which that plant is in northern Alabama. Jon received a B.S. in Civil Engineering from Oklahoma State in 1972. Then he pursued graduate work in civil engineering here at the University of Tennessee. He joined TVA in January of 1973, and he had many different engineering and management responsibilities until he became the chief engineer for TVA Nuclear. And then just a few years ago, he was promoted to vice president for Browns Ferry Unit 1 Restart, which is the closest thing we have in the United States to a new reactor right now, since that reactor has not operated in about 20 years. I should also tell you that Jon is a member of our advisory board. We have, I think, 9 members, and he's very productive and contributes a great deal to our advisory board, which meets at least once a year. The topic of his presentation today is restarting Browns Ferry Unit 1. So, ladies and gentlemen, please welcome Mr. Jon Rupert.
Good afternoon. Oklahoma State Cowboys, we're ranked top 25. That's why I get that plug in as well. Browns Ferry Unit 1, Dr. Lee Dodds said it correctly. Browns Ferry Unit 1 Restart, we're not a new unit, but we are the next one coming online. And one of the things that the whole core management team, which is composed of Bechtel, Stone & Webster, GE, and TVA, is that if we do this well, we pave the path for other nuclear units, commercial units. If we don't, then we could be the death knell. Could be, may not be. So our premise is to do this job and to do it well, and to demonstrate that nuclear is a viable option. And so what I'd like to accomplish today is why Browns Ferry Unit 1. I want to talk through the issues that led to the decision. What did our board consider? What's done to date? What's left to go? I'll give you some fun facts with regard to where we are specifically on that. And we'll talk a little bit about TVA. TVA's service area, this is a commercial plug, so bear with me. Just to let you understand, TVA, we serve a 7-state region. It's Alabama, Tennessee, Mississippi, Kentucky, Georgia, North Carolina, and Virginia. We serve about 8.3 million people. We're a wholesaler of power. We're not a retailer. And we serve about 158 distributors, wholesale power. And we have 62 very large industrial facilities that we furnish direct power to. Our transmission system covers about 17,000 miles, and our transmission system has a reliability of 99.999%. And we're very proud of that because that's better than most folks in the United States. So, and the average retail rate for power is a little less than 7 cents per kilowatt hour. So that ranks us low across the United States. Against the average, we're 25% lower than the average. So if I were to ask Dr. Lee Dodds, and the board's considering what do we need to do we want to build another plant, and if so, what? The very first thing is, do we need the power? Right? And if so, how much power do we need? So I want to walk through that first. Fascinating machine, I like this. And go from there. Did I go the wrong way? Let me back up. Not sure you've got my slides all right. Anyway, TVA resource capacity. We have 31,000 megawatts of baseload capacity. We have 59 fossil units. Not sure we loaded my slides.
Loaded once you go.
I'm going to go forward. Okay. I think there's some missing. But anyway, I'll go ahead and talk. Baseload capacity, 31,500 megawatts of electric. Comes 59 fossil units, 15,000 megawatts of power, 5 nuclear units, that's 5,800 megawatts, and we have 113 hydro units. That serves about 5,000 megawatts. Baseload is fossil and nuclear. Nuclear is first, then fossil. Then we make up some baseload with hydro. Then we go to our peaking power, which is hydro and combustion units. We have 72 combustion turbine units right now. Furnishes 4,600 megawatts, plus or minus. Totals up about 31,500. We augment that with purchase power when needed to hit peaks, if we can't do it ourselves. Baseload capacity, let me go to the next slide. Our baseload plants are at or near capacity right now. So we're trying to figure out, do we need power? So the answer, you can come to the conclusion, yeah, probably. Why? Because the demand for power has increased about 3% a year for the last 4 or 5 years. And we've done conservation and other renewable type sources of power. That doesn't really contribute to the base in significant quantities. It's not commercially viable. So bottom line is we need additional power. I'm going to try your board. We run about 180 different scenarios for the need for power, different market conditions, different sales options, whether we keep customers or not. And our low is this one. This is our median forecast, as you can see right here on this line. We're hitting our median forecast. That's a growth of 3%. This is baseload power. And this is our high forecast. We don't get there on that. So like I said, 3% increase in power, our baseload capacity, we're almost at, they're all stretched right now. In addition, when we look at our peaking power, same scenario, we have 3 common forecasts, about 190 scenarios for peaking power as well. This is our low, this is our median forecast, and we've hit peaks. We used to be a winter peaking utility. Now we're a summer and winter peaking utility. We have sufficient capacity right now with our peaking options to go through about 2010. And then we can make up for that with purchase power when needed. So the bottom line is, do we need power? Yes. If so, how much? Bottom line, it comes out, we need about 1,750 megawatts of baseload power through the year 2010, more than what we have right now. Like as I said, peaks, we can hit it with our existing thing. And then with our existing plants. Need for power, do we need it? Baseload capacity, 750, you bet. So now you're the board. What's your next question? What are my options, right? If I need the power, where's it going to come from? What's my generating options? What's a good business case? Our business case, we compete against business cases for nuclear or coal-fired plant or combined cycle gas turbines against the market. So we have to compete in the marketplace. So whatever it has to be a good business case relative to the market. If it's not, then it makes sense just to go buy the power, right? If it's not commercially viable. So we'll go through the areas to consider. Generation options, is it cost effective or not? And I'll get into all of these in a little bit more detail in just a few minutes. Look at nuclear. Well, I want to say one thing about nuclear. If Browns Ferry 2 and 3 had not been performing well, or if TVA Nuclear not performing well, which would include Sequoia Units 1 and 2 and Wattsbar Unit 1, Browns Ferry Unit 1 would never have been considered at all. TVA Nuclear, our 5 units in generating capacity for 2003, just for example, I think Browns Ferry is ranked 4th in the nation for net capacity, and Sequoia is ranked 5th. Wattsbar Unit 1, a single unit plant, is ranked 12th. Out of 102 units or 104, that's not bad. If we weren't doing that well, nuclear would never be considered. So for additional capacity, point 1, to be considered whether it's Browns Ferry or not, the nuclear industry has to perform well. And that's extreme attention, and I can preach a different hour-long course on that or two. So, because we were running well is the reason Browns Ferry Unit 1 is considered. Environmental impacts, we did a full environmental impact statement. I'll walk through that. And we did a full economic evaluation, which I'll get into in just a second. Generating options. Get right to that. Natural gas fuels combined cycle. We compete against that market constantly every day, every hour, as a matter of fact. Do we do nuclear or new plant, or do we look at a restart, Wattsbar 1 or Browns Ferry, Wattsbar 2 or Browns Ferry Unit 1? Coal gas, a new fossil plant, whether it's pulverized coal or a fluid bed option. Look at energy storage and other renewables and the demand side of our management cases that we look at, and do we buy. Given that, I'll start at the bottom. Energy storage, renewables, demand side management, TVA does that right now. We do it, and it's in a small scale. Why? The market's not mature. It's a green switch, right? And it doesn't cost compete in our marketplaces. However, we still offer them. That kind of does away with those options. Basic choices are nuclear, gas, and coal. Gas prices, there's very low margin of combined cycle gas turbines. They drive the marketplace day in and day out, hour by hour. And that's what we looked at. And we compete against that. Coal gas isn't competitive just because that technology has not been developed to full extent. So the options that we competed when we evaluated for the base load capacity, what are we going to look at? Restart Browns Ferry Unit 1. We didn't look at new nuclear just yet because Browns Ferry Unit 1, we think, at the time presented a better option for us because it may have a large capital investment, but it's got a very small O&M increase, and I'll go over that in just a few minutes. We competed against gas combined cycle, new power purchases, plant in the market, and renewables, but the renewables fell out quickly, like I had already stated. We're going to look at cost, schedules, and risk. For me, when we presented this to the board, all these were, think of your orals, think of a real bad set of orals, a bad day. My orals in presenting this to the board was 4.5 hours in going over this, why Browns Ferry Unit 1. All these issues were discussed, so I'm condensing my set of orals into about 50 minutes, so bear with me. We clearly demonstrated that the nuclear industry overall is doing better. I'll give you a fun fact. Nuclear plants generated 252 billion kilowatt hours of electricity in this last year through April. That's 1.6% higher than our record-setting pace that we did in 2001 as an industry. That's outstanding. Our net capacity factor nationwide is 90.8%. That means you're running almost 91% of the time when you could be. Subtract out refueling outages, down powers for moving rods, whatever. That's not bad. Yeah, like I said, we're ranked 4th and 2nd in the nation. I misspoke. Browns Ferry is 4th, Sequoia is 2nd. Wasbar is 12th in the nation by Nuclear Alliance Week. That was just published for 2003. Browns Ferry, a fun fact, since I've spent a lot of my time there over my lives, Browns Ferry operated breaker to breaker, 669 days, set the second longest run in United States history. At the front end of that, when we went to that, we had a world record outage of 18 days. We ran 669 days. Then we had, which I'm really proud, a 14-day, 16-hour refueling outage. If you've ever worked at a nuclear plant, that's outstanding, world class. We're also INPO 1, all 5 units, and that's a lot in the consideration. Back in 2002, actually in 01, the board asked that a detailed scoping, estimating, and planning. This is the next step in doing any nuclear plant. Whether you want to do a brand new one or not, or you want to restart one like Browns Ferry Unit 1, you have to understand the scope, you have to understand the technical risk, the regulatory risk, the financial risk, and you have to do detailed planning and scheduling. That has to go in, and we did all that before the board ever approved what we did. They asked that we do that and sent us to work well before authorization. They gave us 6 months, said you go put together a team, and we did that. Brought in 10 managers from TVA that all had previous restart experience at Browns Ferry, Units 2 and 3, Sequoia, Wasbar, and other restart experience outside TVA. We brought in 78 key managers that had restart experience from Bechtel and Stone and Webster to help us do our detailed estimate. And from General Electric, we brought in about a half a dozen or so really key folks. They're our NSSS supplier, and they know a lot about our systems. And since we're doing an extended power uprate, which I'll talk a little bit about in just a few minutes, we needed to understand what all that would entail, because that's reworking the whole secondary side of the plant, plus a little bit on the pressure vessel, right? Just a little. 6-month study to confirm the scope and the risk. Really experienced folks, and spent a lot of time doing that. Things that we looked at doing were how do we optimize our return on investment, get the most for our money? How do we clearly define the schedule so that we can lay out a schedule that we know that we can meet? How do we lay out the budget so that we can understand how to march that? By the way, we're slightly ahead of schedule, and we're on budget today, 50% of the way through the project, $1.8 billion project. And we also had to take into consideration that we're working in a Unit 1, Unit 2 and common systems are integral. Unit 2 has integral systems, has operating systems in Unit 1 spaces. How do we protect the operating units, i.e. don't trip or cause runbacks? That's a nuclear no-no, right? So we don't do that. We also had to assess materials availability and is there manpower in the industry to support this, whether it's the engineering resources or the craft resources to do our work. These are all risks that we had to define. Our key premise was, though, that when we do Browns Ferry Unit 1, it will be exactly the same operationally as Units 2 and 3. Why? We want the operations staff and the maintenance staff not to have to deal with significant differences. So our premise is we will restart Unit 1 just like we restarted Units 2 and Unit 3. So we'll do everything that we did when we restarted them. We'll do all the modifications since restart, plus what was on their 5-year plan through 2007, which we've done, and it's well underway right now. Return on investment. Browns Ferry is an older unit. It had a 40-year license live, which was up in 2013. We've applied for license renewal for Browns Ferry Units 1, 2, and 3 that extends Browns Ferry Units 1 license to out to 2033. I will be at the beach at that time. Okay? And so one way to do it, give the units longer life. That is an extensive review by the staff of active, but principally focused on more passive systems. That's a whole nother talk all by itself. We also are doing an extended power uprate. Units 2 and 3 had done a 5% uprate from 1,100 megawatts electric to 1155. We're doing 120% uprate for all 3 units. Unit 1 has the lead. So we're taking it from 1,100 megawatts electric, and I'll go through some fun facts of what we're doing to do that, to 1,280 megawatts. That's a big deal. And it makes the return on investment very attractive. Any other things on this slide? We also did detailed estimates. We had done this work twice before. If you think about the other 2 previous restarts, the plants had made a lot of mods from the time they restarted through when we started this restart ever in 2002. So we had those experience bases. So then we factored in what was in the base. So point number 2 that you need to remember about new plants is, do one, duplicate it. Do the engineering once, get it right, make it safe, make it operationally so it makes sense and easy to run, and where it can be easily maintained. And then you duplicate it. That's what we did. That's a very strong premise for going forward in the nuclear industry. I'm going to plug that. You'll hear me say that probably about 5 more times. Detailed planning and estimating. We know how much this plant costs. We're dead on the cost. We haven't missed it. We're not overrunning. We've just re-estimated the job to finish. It's still on within our money. Amazing, right? And we're still able to, we're beating the schedule. Okay. Detailed planning and scheduling. Third point. You've got to nail it. You got to know it inside and out. If you want to do nuclear, no guess, no incremental disclosures, and no all shucks. Okay? I missed it. It ain't allowed. That's how you kill the industry. Materials availability. All of the suppliers in our used-to-bes are basically out of business. If you want to buy valves, there's only 2 major valves producers in the United States now, not 15. If you want to buy pumps, motors, switches, relays, most of them are out of business. So we had to go find them. We had to go make sure that they could meet our demands because we knew how many we were going to buy, and to make sure they could supply it to meet our schedule, because we have outrun some of our suppliers. But that's another case. But we did those risk evaluations. We cinched up the contracts early on. That's a major risk item. Plus, the suppliers aren't used to supplying their materials to nuclear standards and expectations. That means it has to be what I asked for. It has to perform the way I expect it to. They're used to supplying stuff commercial now, because we've not been in the industry. Well, we've had to work with our suppliers a lot to do that. That was laid on and estimated up front. Manpower. Recession is a wonderful thing. We started this unit right at the restart right in the middle of a recession. That made more resources available to us, but we did a complete evaluation of, are there engineers in the industry that can do this work? Are there contractors, AEs, that can supply them, even find them, get them to the job site? And are there craft available that can do this? Right now today, we have 2,400 people on this project. We ramped up an engineering space a little over 580. We're now have de-staffed significantly because the engineering is behind us. But we weren't sure going in. We confirmed that during this detailed study. Resources are available and can be brought to bear when needed, and are competent and trained. The items in the risk review. When we shut down Browns Ferry 2 and 3, they were called troubled units. That's because we had lost configuration control of the units and weren't running the units in accordance with our procedures. We no longer do that. We fixed all of that when we restarted Units 2, and have subsequently refined that in Unit 3. They run well now. We follow procedures. We maintain rigorous configuration control. We had a lot of work that we had to do with promises that we made to NRC. We will do these programs, seismic qualification, how we do ampacity and cable separations, for how we do Appendix R, fire protection. Any issue in the nuclear industry you could think about, we've addressed. That was in the nuclear performance plan right here. We also had to ensure that this station, when we're finished, would meet license renewal or life extension issues, run an additional 20 years. Those evaluations were done. All licensing risks we had to address. Our major licensing risks were boiled down to extended power uprate and working with our Nuclear Regulatory Commission staff, and license renewal because the unit's not running. It's a little bit different. Two major ones, we got those basically behind us. Those submittals are with the staffs. We've been working with them for 2 years now. Current wage information, we walked the plant down, part of our understanding rigorously. We had to figure out what's there, what's not, what's been borrowed over time, right? And what's it take, what doesn't work anymore, rigorously. Operational assessment, what's it take to run this unit when we're done? What's the staffing look like? All maintenance work orders, what's it take to make the units exactly the same operationally? Some geometry, configuration differences, but not a lot. Corrective action programs, a lot of things. Pricing, working with our marketing folks. We worked through all these issues. Detailed study covers 13 3-ring binders, if you want to talk about volume. That's just the summary stuff, and then it blossoms from there. It's a huge amount of data that we did in doing this detailed study. Bottom line, we said we know it will cost $1.732 billion, but if you want some comfort, we'll range it to $1.817 billion. It's not million, it's $1 billion. The project schedule was from the day the board authorized it. We promised that we could deliver this unit in 60 months. Detailed estimate, detailed scheduling. When we went to the board, to give you an idea of scheduling network, we had a 40,000 activity network that detailed it out from the very beginning, from the day we turned the first engineering calculation to the day we closed the breaker 60 months later. It's changed, it's huge. And we went over our staffing in great detail. Right now we're right at 2,400 folks. We're right at our peak staffing. We'll really peak in December or around 2,480, something like that. To give you an idea of what this project looks like, 60 months schedule is to close breaker, getting ready to do power ascension testing. Engineering programs, the engineering analysis work, the engineering and analysis, not counting design work, was 1.4 million man-hours of work, round numbers. The design work, and that's all done, it's behind us, that defines the breakage. The design work was 1.3 million man-hours of work. That's all behind us as well. So all the engineering and all the design is done and behind us. It's another key point for a nuclear unit. New nuclear units, get the engineering and analysis work and all the design done and get it behind you so you know what you have to deal with. So you can do detailed estimates. That's also done going forward. And we've done this, all the detailed mods and demolition work. in the dry well. This is a BWR, right? Let's go out the bottom. And, right, that's not what I looked. And we basically gutted the dry well. That means we took out all the piping, all the electrical cable and raceways, pumps, motors, and valves. Took everything out. You can go in the dry well just like you're dressed right now in street clothes. You stay in there for 4.5 hours or 5. It runs about 70 degrees because we keep it air conditioned. And we're putting everything back now. And you'll pick up no dose. For no BWR, that's not bad. I went through it 3 weeks ago, spent 2.5 hours, all the way up to the top of the dry well and back. It's up to 3 levels. And climbed over all kinds of piping. No dose. 0. We're running, we estimate by the time we finish Unit 1, we will, and we're doing a lot more work, we will do approximately 40% of the dose that we experienced when we restarted Unit 3. We've done a lot of decontamination work inside the systems to remove them, to clean it up, to remove Stellite 6. That's another hour-long session. But we're detailed planning right now is on restart test. We won't start that for about 16 months. But we're finishing up the detailed planning of restart test that leads to the start of power ascension testing, loading fuel power ascension. Right now we'll finish that in about January of this coming year. And we're beginning to put meat on the bones for our power ascension testing program. This will be about 2 months. But we're definitizing that right now. The considerations in doing the economic analysis, we did a 20-year license renewal. Gross megawatts, 1,280 megawatts of electric. Capacity factor, we estimate to run around 92.7. Average value, that's real good, by the way. But Browns Ferry runs around 94. The other 2 units, not bad. Capital cost, $10 million a year. That's to do improvements. Fixed O&M, that's production and labor. It's $23.5 million a year. That's the incremental increase in O&M costs for the Browns Ferry unit. That's what makes this thing so attractive. Right now, Browns Ferry has about 800 folks for 2 operating units, units 2 and 3. Incremental staff increase is less than 150 people. So you want to know why we're economically viable. That's the reason. Outages run about $18 million. We're on 2-year cycles. And fuel, around 4.5 mils per kilowatt cost. That's what our estimate is. We went from, we run Browns Ferry Unit 1 was shut down as 8x8 fuel. Now we're going to 10x10. We used to change, to do extended power uprate, we used to change out 1/3 of the core every cycle, every 18 months. We're on 2-year cycles. Now we'll change out right at half the core every 2 years. And we've designed it so that we run flat year-round at 1280. When it turns cold in the wintertime, we don't lose power, or in the summer. Bottom line, extraordinarily detailed study before we presented to the board. That's where I did my orals, the real ones. It's 4.5 hours worth of being grilled by the board and all the senior folks in TVA. High level of confidence that the project can be completed for what we said we can. We've clearly demonstrated that in the time that it takes, that we said it would take. We've clearly demonstrated that. That's what you have to do on all new nuclear units. You have to nail it. And the risks were extraordinarily well defined. Environmental impacts. We did a full-blown supplemental environmental impact statement that addressed this is the way that you also had to do an environmental impact statement. I'll do it this way. We did full scoping. We let all the state agencies know, federal agencies, local folks that were interested. Had scoping meetings and public meetings well before we did asking for public participation. TVA conducted extensive studies with regard to air, noise, water, air pollution, anything that you could think of, we evaluated it. Effects on the river with regard to heated water discharge and or entrainment of small fry. Gave a full EPA notice, did the studies, finally EIS was issued. We gave 2 public notice periods after that for public review. The few people that came all supported it. The public was very supporting, which we were very pleased with. The alternatives that were considered was a do nothing, forget Unit 1, doing an extended power upgrade on 2 and 3 and extending the license on 2 and 3 only, and looking at Unit 1 in with 2 and 3. We also looked and addressed additional cooling tower options that we've done. We'll be adding another cooling tower, about 20 cell tower for additional cooling power capacity. Reevaluated spent fuel storage. Since DOE doesn't take our spent fuel, we had to evaluate the impacts on dry cask storage at the site, which we are also implementing right now. Pads are built, getting ready to start receiving the big casks to store. And the impacts on the site while we're there with all these 2,400 folks. Let's see. Noise, spent fuel management, socioeconomics, and radiological impacts during our modification period, construction period, and while the unit's operating. Bottom line, no significant or unacceptable impacts were identified from operating units. Another 20 years or on restarting Unit 1 for the extended life of the facility through 2033. And that's what we presented to the board, and they accepted. Money. Now that you know which options we've looked at, now there has to be a good business case relative to the market, right? The assumptions were I'm going to use $1.8 billion job. That does not count interest during construction. Start up, that means throwing the breaker, would be May of 07, 5-year period after board approval. End of term for the license would be 2033. Net capacity is 1280 minus house load. That's 1254. And load growth of 2.1 to 3%. So, and a capacity factor of 92. That was the assumptions. What's this mean? We competed heads up against combined cycle gas turbines, and when you look at this part of the curve, which is an early on short-term period, combined cycle gas turbines, gas operates on very low margin. So we compete even up. However, in the long-term view, this is Browns Ferry Unit 1. This is combined cycle gas turbines. Dr. Dodd, what does that say? Which, if down is good,
Go nukes.
go nukes, right? That's one way of looking at it. We can beat them on pricing by a factor of 2, bottom line. Another way to look at it is a very simple all-in cost. We are right here right now. The blue line is our expenditures of the $1.8 billion. Right here is where we lock onto the grid when we close the breaker. This green line right here is the accrued interest on the investment during the period. So we close the breaker, that means we start paying for the investment. What happens from here to here? When you get to break even, or we go back to 0, that means we paid for the investment of $2.1 billion in a little less than 8 years. How's that? Make sense? We outcompete any other, Browns Ferry Unit 1 outcompetes other options like combined cycle gas turbines and unit, and we pay back all-in costs in less than 8 years. Do you know what this time period right here is called? Cash. Okay? That means it makes money. Good long-term business decision, and that's competing against the market. To do this in new nuclear plants, the first one or the first two, you've got to nail the engineering, and then you duplicate it, right? I'll keep saying this over and over and over. You do detailed estimates, and you perform against what you say you're going to do. You set the schedule, you set the cost, and you nail it for that. It gets cheaper going forward because the next ones become easier because you've done it before. Make sense? We're demonstrating that at Browns Ferry right now today. All this means is that Browns Ferry becomes less than penny power. That's a good thing. Tonight we dropped all the cost of TVA power in 9 mills, Unit 1, all by itself. Summary, I'll talk about this in a minute. Let me give you some extended power unit, what it takes to upgrade that. Browns Ferry, megawatts thermal, it's 1,100 megawatt electric unit originally. That's 3293 megawatts thermal. A little increase, right? So we're going to take it to 3952 megawatts thermal. Megawatts electric go from 1,100 megawatts electric to 1,280 megawatts electric. Reactor pressure vessel, what's it take to do that? The pressure, PSIG, is 1,005. We had to increase dome pressure, took it to 1,035, increased steam flow, right? The temperature originally is 547 degrees Fahrenheit. We're taking it to 550.5, round numbers. That's part of the extended power upgrade. Steam flow, we're 13.37 times 10 to the 6 pounds per hour. We're going to 16.44 times 10 to the 6 pounds per hour. Fuel, we're doing 8 by 8. Originally, we're doing 10 by 10. Now, third of a core discharge every 18 months, way back when. Now it's 50% of the core on 10 by 10 every 2 years. That's an extended power uprate. That's the NSSS side. That's really about all you're doing. You're increasing steam flow. What's that do to your secondary side, Doctor? You know what you got to do? Let me ask.
Well, you need a better heat sink.
If I'm increasing steam flow, that means I got to get the steam past the HPs, high pressure turbines, right? Well, I got to replace that. Got to replace the low pressure turbines. I got to change out extraction steam and steam dumps, right? Yeah. Got to increase feed flow. I got to increase and get a whole lot more condensate flow going and condensate booster pumps going. I have replaced all of the carbon steel on the secondary side because of back and erosion and stuff like that. So we've already replaced it with all 2.5% chrome moly stuff. Really neat. Replace all the pumps, motors, and valves. All right. Put chilled water on your stator. Yeah. Rewind your generator, which we've already done. We just finished that this week. And then we put it back together again here over the next month or two. Replace your main banks, transformers. Right? Yeah, all 3 of them. Replace isophase bus, replace the coolers to them, redo 2 substations off-site, add new bays, and run a new miles worth of new conductor in the transmission system. That's what that means. Round numbers.
Oh, that's really expensive.
Say again?
That's really expensive.
Yeah, it's all in. It's all in. Right there.
Who is the turbine vendor?
Say again?
Who is the turbine vendor?
GE. Summary. Need for base power, that was clearly identified. Confidence to complete Browns Ferry Unit 1 within the cost and schedule, you bet. Detailed study, detailed evaluation, detailed scoping, detailed estimating up front, and then you have to do it. We are. Positive environmental impacts, positive impact on cost of power. You have to compete in the marketplace. You have to present a solid business case relative to the market. The units are going to be exactly the same, right? Told you that. Operationally the same. We're the first to do extended power uprate. And let me go to where we are. On schedule for May 07. Actually, we're a little ahead. Look, we're on budget for the $1.77 billion. We're right at our 50% complete point. Our budget that we're winding up, our fiscal year ends on September 30th. Our budget this past year was $373 million. Our budget next year is $444 million. And then we wind up in 06, just bulk modification work for 05 and 06 running, and I'll tell you what those numbers look like in just a second. The engineering, I told you all the engineering, design, and analysis work. We finished all the engineering analysis calcs, established a complete design basis for the unit in an extended power operating condition. Finished that 43 days early. We de-staffed as planned, and supporting mods work. And there's a total of $4 million. The bulk of that's behind us now. The engineering is now focused on supporting mods in the field, maintenance in the field, scoping out and getting ready to restart tests in about 14 months, and then power ascension testing, putting meat on those bones. That's what the engineering is doing right now today. Mods work, more fun fact. Oh, the design work. I'm going to go backwards. We produced 258. Now, this is consolidating what we'd done before. We reviewed during Units 3 restart about 400 and some odd design changes, another 300 since restart, and then another 150 that were planned on the books through 07. We consolidated all that and issued about 258 design documents. Design change, those is what we call them in our vernacular. That's 112,000 pages of stuff, round numbers. 8,000 drawings. So that's where we are in engineering space. Demolition work, we took a lot of stuff out of the dry well, pumps, motors, valves, coolers, everything went. We completely deconned it. We're putting everything back right now. Major mods, generator rewind, we just finished that. That was a good hunk of work. GE did that for us. Moisture separator work, we're changing out the internals, the chevrons and everything to the internals for moisture separators, increase efficiency. That gave us about 8 megawatts all by itself. We're replacing the HP and LPs. The machines are being built. We'll be receiving them here in about 6 months. Feed water pump rotating element, that's being fabricated right now. We'll be receiving it in about 9 months. Condensate booster pump and motor, complete new change out and increased piping size, increased condensate flow quite a bit. Carbon on the secondary side, we had carbon steel, highly susceptible to flow accelerated corrosion. And so we changed all of it out, extraction steam, crossover piping, big pipe, that's all done. And 2.5% chrome moly, good hunk of work. Reactor water, coolant water, and RBCCW heat exchangers, we've replaced them. They're being set right now. Piping's getting ready to get hooked up to it. You can walk in an BWR in operating spaces. The reactor water cleanup heat exchangers room is an extraordinarily high rad area. You can walk in there in your street clothes and lean up against them right now. Everything's brand new and decon, no dose. Main banks transformers, we're getting ready to take them out. The new ones are on site. We've received them. And there's 104 tired trailer that brought each one to the site. Received them by rail. Fun facts. We painted 78,000 square feet. We've got another out of 299,000 square feet of painting. Cable tray hangers. We've done 1,239 out of 1,399. We're almost done with cable tray. Cable tray itself, we've installed about 6,500 feet out of 8,600 feet. Not to the big numbers yet. Conduit hangers, we've done about 1,400 out of 14,000 planned, so we're getting ready to run conduit. We're in the midst of that. That was conduit hangers. Conduit, we've installed about 11,000 feet of conduit at 134,000 feet of conduit. Small bore hangers, that's less than 2 inch, right? We've installed a couple hundred out of about 5,400. Small bore pipe, we've installed almost 1,400 feet out of 23,000 feet. Large bore hangers, 2 inch. We've installed about 340 large bore hangers to date out of about 1,800. That's my critical path. We'll get the hangers and the pipe up. 4,600 feet of large bore pipe out of about 12,000 feet. When we get all the raceway built, we have to install about 870,000 feet of new cable, about 600 and some odd thousand terminations, because you got to lift the cable and reland it. Big numbers. On schedule. Restarting a new plant is a fun work, guys. I have a blast. I work with a good bunch of folks that are there because they want to be. We all know this is a legacy issue for the industry, and the whole core management team knows and understands that. We're there because we want to be. I hope y'all are, really and truly, because there's more to be done. We do this right, I guarantee you there's more to come. A lot of folks are looking. But the deal is, you got to do the engineering and design for the next units and settle on one and get it safe, easy to operate, and easy to maintain. Duplicate it. Track housing is a wonderful thing. We've demonstrated that once you've done a couple of these, you can do the next ones even easier. Because you bring all the lessons learned forward, and you incorporate it, and you do it well. Detailed studies, detailed evaluations, and work to the plan. It's called build the plan, work the plan. Lift and shift quickly. We entertained the Deputy Secretary of Energy at Browns Ferry. We entertain a lot of folks at Browns Ferry right now. And then went to Bellefonte. TVA and DOE have signed a little contract, a little $4.2 million project to look at advanced boiling water reactor concepts, right? Yeah. So there's more to come. Hang on. This is an exciting industry. Y'all just need to enjoy it. I get this one done, I'm going to the house. You all need to do the next one as well. Questions or comments?
Okay. We have time for a few questions and comments. Okay, Mario.
Understand for license renewal for a plant that's been running, you really don't have to qualify the equipment that's been running all along and you've been maintaining it all along. You have to look at the past system. So in this case, it hasn't been running any equipment.
Right.
So what do? You have to rebuild the thing from scratch, or say you have a pump or something like that?
We are. We've demonstrated that all the piping systems, they look at passive systems, right?
Yeah.
We're replacing all the cabling,
Yeah.
all the piping.
Got to do that, but you also have to look at active system because you haven't been running your plant.
Right.
Right.
But I have two that look just like it.
Yeah.
So I can demonstrate how it will perform. That's what we've worked with the staff on. We can demonstrate very clearly that Browns Ferry Unit 1 will be like 2 and 3, right? They're exactly operationally the same. Passive systems, we've built brand new. And where we haven't, we've gone in and refurbished.
An additional question, is the infrastructure available? Did you have to use foreign engineering or foreign workers? Or were there enough people in this country that could pull off existing jobs to work on this thing?
Yes, there are. It was amazing. The result was we found that with engineers, we had some training to do because we're very sensitive to human performance and having no issues or errors. So we had additional training to do with regard to how we did that. And the craft, we found everybody. We have, of our craft workforce, which is about 1,400, 40% are local. The rest are travelers. and we found training issues with them as well to work to our standards, and we provide that training. So it can be done.
Okay. We do have a question from cyberspace. This question comes from Kirk Sorensen, who's with the NASA Marshall Space Flight Center. That's in Houston, right? Mr. Rupert, based on TVA's need for additional baseload power in the near future, what are the prospects for completion of the Bellefonte reactors or the construction of a new type of reactor on that site?
Okay. First of all, TVA nuclear has to perform well. We said that, and continue to perform well. We had to bring Unit 1 in on time and on budget. We are participating right now with DOE in evaluating Bellefonte and additional advanced reactor concepts. So we're pursuing that right now.
It's the ABWR, not the
ABWR.
not the boiling water reactor.
Yeah.
Okay.
So is there a potential? If we, like I said earlier, if we don't do Browns Ferry Unit 1 well, or our units don't run well, I'm pretty sure that's a death knell. That's my own personal opinion. If we continue to run well and we do Unit 1 well, then I'm convinced there's a future for nuclear power in this valley.
All right. Other questions?
You mentioned 10 by 10 assemblies. Are these used in other units?
Yes, yeah. We don't do first-of-a-kind fuels. I'll answer the question that way.
That's smart. We don't either, do we, Gary? We don't do. We test everything. Okay. With that final remark, let me point out that we do have refreshments downstairs, as we always do, and everyone is invited, even the people who've never been here before. And you'll have the opportunity to ask more questions and talk one-on-one with Mr. Rupert. But before we adjourn, let's express our appreciation again to Jon for his service. Okay.
Not really. Oh, I've watched it. I knew where to skip.